Hello and welcome to Dorleco. My name is Alex, and today I will introduce to you our latest product for EV controls and software developers, the SmartBench, providing an overview of the components and the flashing process to demonstrate some of the possibilities for automotive use and embedded systems testing. Let's dive in. So before we begin, I want to talk a little bit about some of the challenges that early stage EV control development companies face. You can see here is a fully electric RUV that we recently integrated the controls for. So the battery, the motor, and the inverter are in the high voltage loop, and the body control functions like the power windows, driver display lights, door locks, etc. are all in the low voltage loop. To integrate all the electronic systems and seamlessly control them over several controllers on a vehicle or a hardware and loop bench is very expensive. The only cheaper options being a software in loop or model in loop, but they aren't meant to replace hardware in loop or in vehicle tests. The SmartBench bridges the gap between insufficient software in loop or model in loop testing and expensive hardware in loop or in vehicle testing. It comes with all the necessary components, it's portable, open sourced, and can be configured to build electrical and electronic setup for two-wheelers, three-wheelers, four-wheelers, boats, drones, and off-road EVs in just a few minutes. Let me show you the setup we have built for a half-ton EV. The first component you would get is an auto-grade throttle pedal with a dual sensor, and it is CAN compatible and can also send digital outputs. The pedal signals are routed through the control case, which has a 7-inch SmartView CAN touchscreen, a 15-key CAN keypad, digital input switches, and a wiring harness for the VCU. The control case has an Ethernet port in the front, serial port, digital and analog IOs, and multiple CAN channels. Let me show you each of the components in brief. Next up is the Easy Press CAN keypad. This has an NXP 16-bit or Renesas 32-bit processor, extremely easy to program and customizable. I have a 15-pin version here, but you can go with 2, 4, or 8 keys. The icons that you see on each button are also customizable. You can choose from a library of 2,000 icons. For now, I will show you some of the basic drive functionality and cruise control in action as well. So this is the 7-inch CAN touch display. It is fully customizable and programmable, meaning you can change the graphics, text, etc. as you want. Currently, I've programmed it to show the functions that you see on the screen, like speedometer, drive modes, and some other base EV info. Also, there is touchscreen support that can be used too. And of course, this can all be customized through software. The screen is CAN compatible and has a programmable STM32 processor. The most important piece in the puzzle is the VCU and the software. Here's a SmartCase Pro VCU that comes with free flashing and calibration tools. You can choose either SmartCase Pro or SmartCase Easy. Pro comes with all the advanced compute module with Wi-Fi, GPS, LTE, Bluetooth, and IMU sensor. Easy is good if you are working on powertrain or any domain controller for that matter. You will also get a traction motor of your choice along with the bench. Here I am using a BLDC motor for a half-ton EV application. This is a high voltage motor, but you can choose what voltage you want when you order. Here's the motor controller, which is also CAN compatible, and you will get a compatible motor controller based on your motor selection at the time of order. Finally, the lithium-ion battery and the BMS. You can choose the battery type and voltage you are comfortable with at the time of placing your order. The BMS talks to the VCU over CAN, and if you are using the SmartCase Pro, it can talk over Bluetooth as well. So now I'll demonstrate how to flash the VCU over an Ethernet connection, and we're going to make a simple change, being the color when you press a button. Instead of green, we'll turn it to red. So before flashing the VCU, you'll want to make sure your computer has access to the hardware. So through the virtual here client, I'm going to select my device and then hit use this device. So I know from the documentation of the keypad that this value here is what indicates the backlight color, and the 2 is for green. And all I'm going to do is change it from a 2 to a 1, which should be for red, and then all I have to do is hit Control B, which will build the L file, which I can flash to the VCU. So now in S32 Design Studio, I have my target device specified here with the correct model number. And then I have my ELF file, which I just recently built and showed you through Simulink. And all I'll have to do now is hit flash, and the process should take about 15 seconds, and then you'll hear a beep from the VCU indicating that the process is complete. So now that the flashing process is complete, if I press one of the buttons here, they will now be red instead of green. Simple as that. So now that our setup is complete, you can see on the keypad that drive mode is selected. And now if I press down the throttle, you'll see that the motor responds accordingly. So if I press it more, it's going to spin more. And you can also see on the computer, the RPM data is being logged there as well, and that can be analyzed later. But what I can do on the keypad is hit the ACC button, which is our cruise control. And then directly from the keypad, without touching the pedal, I can turn down the speed, and I can also turn up the speed. And you can see these changes being reflected in our data here. In conclusion, the SmartBench offers a comprehensive solution for your automotive engineering needs. You can have your personal EV lab in the classroom, office, etc. If you have any other questions or request any further information, please feel free to reach out to us at info@dorleco.com. Thank you for watching.